Number 6 had to do with security. So everybody is good with governance and compliance, right? All right. So let's talk about. We're almost there. We're almost at the end of all these benefits. Security. Security again is a huge benefit, and it just comes second nature. Why is that? Because what is the definition again of cloud computing?
Delivery of cloud services over the internet.
There you go. It's as simple as that, depending on what service you want. If your server is using files, you're delivering files. If your server is saving a website, it becomes a web server. If your server is saving a database, it becomes a database server. If it's firewall, it's a firewall server. There's all different types of servers. There's even a print server. There's also a fax server and so on. So if cloud computing is in essence delivering all these services over the internet, that means their primary goal was making sure it's secure. So the only part that we have to decide on now is we have a choice to choose. How do we want to manage the security? Do we want to use infrastructure as a service, which is just going to give us the hardware and then we will have maximum control of our security? Or do we want to have less control of our security? We just trust that, hey, you know what? Amazon Web Service or Google Cloud Platform or the Microsoft Azure, we trust them enough. They're already set up. They've shown us their SLA. We know that their platform as a service is going to work just fine, or software as a service is working just fine. For instance, an example of software as a service is Gmail, right? Nobody has a server in their house that they are using for their Gmail, but we trust Google that nobody is going to get into our email. So we're using Google server that's located all around the world to be able to save our emails in a server somewhere on Google Cloud. So that's an example of us choosing that as the security. Now, we know obviously that banks, financial institutions, right, health institutions, and also military institutions, they probably don't trust their data to be out there. So they might want to set up infrastructure as a service. So if you're going to work in any of those cases, you will most likely be dealing with infrastructure as a service at some point, because they want all their data to be in-house, all their hardware to be in-house. Because like we said again, the data can be breached either physically or through the web and different other ways. So we'll talk about defense in depth later on. But with this, you have the option of choosing how you want to manage your security.
Yeah, I have a quick question,
Yes.
Vitus. Like your email, that is software as a service, right?
Yes.
Okay. And the software as a service, your email now, as far as security is concerned, it's basically ensured by the provider, right?
Yes.
And why is it that sometimes, how strong is that level of protection by that provider, considering the fact that sometimes we get some spam, some hacked, some kind of compromising email sent to a personal email, which when you open, then it takes control of your email and things like that. So why is it that possible that the provider can't really give you that sufficient protection, or there's always kind of a lapse in every circumstance?
Very, very good question. And this will be a good question for Blazo or Egbert to answer, because those guys have experience with cybersecurity. But I'm going to try to answer it for you, okay? So with cybersecurity, that's what we are talking about here when we talk about spam and so on. There are different types of threats. There are physical threats. There are malware. Malware, again, is just short form for malicious software. The malicious software comes in many different types. And then you also have social engineers. Social engineers are, in other words, scammers, right? Social engineers, they take advantage of you and they have their principles and so on. They either get some kind of urgency or they use some other threat or, different techniques to be able to approach you and fool you to grant them access. The only way this is possible is if you grant them access. You can have 1 million people sending you spam email. As long as you don't open it, they will never have access to your email. But the moment you start giving them your password, your personal private information, then you're giving them access to it. That's why you hear Google, Yahoo, all these email providers, they'll tell you, we will never request a password from you or any personal information. You're taking it and saving it in there. The only way anybody's going to get access is if they trick you. They use social techniques to engineer you into giving them that information, and then they hack into your system. Does that make sense?
I remember there was a time that I know, okay, if you don't give your password access to your personal information, but there are times where an email can come to your box and then you open it. Maybe opening that email is also another form of you giving access.
Exactly.
You open it and then you realize that the email has been sent to so many people.
So like I said, right, not to cut you short, there are many different techniques. There are many different ways that it can be done. Even with your browser, even with you downloading software that you're not supposed to download, even with you just going to a different website, they get access to your website, they start monitoring your keystrokes and so on. So at the end of the day, this is a whole different topic, which is not something that we can cover today or even in a week. But there are many, many different ways. At the end of the day, all you want to do is, if you get an email from someone that, they might be faking it and giving you my name, but the link is something else, and so on and so forth, you just have to not fall prey to that. That's why I discourage people from forwarding all these forwarded messages up and down, whether they are true or they are not. Don't forward messages all around, because I could create a malicious website, forward a message to you with a link, 10, 20 people click it, it becomes something else. So that's a whole different topic on its own. But that would be a weakness that is going to be something that you propagate. So viruses are usually effective only when there's human interaction. If a human does not click a button or does not go to a website or does not do anything, then it's not going to happen. So again, that's a whole topic that I can take 3 days to talk about it. But it's beyond the scope of this class, so let's not go into it. But in the same light, there is an example, as you see on here, robust and secure. We're talking about distributed denial of service. What is distributed denial of service? So denial of service attacks, an example I can give you is, let's say you go to a bar and you order a beer, right? The bartender goes and grabs a beer and gives you back. That is how a request usually goes on a website. One person clicks on a link, it sends a request to the server grabs the resources that it needs to grab and bring it back to that person. But if you have 10 people requesting for beer at the same time, what's going to happen to the bartender? The bartender is just going to crash and burn, So imagine somebody knocking on your door, maybe a Jehovah's Witness, you open the door, and then after 10 minutes, another person knock, and then the whole crowd is knocking on your door. You will end up not being able to serve all of them. You deny them service. So denial of service is an attack that is very prominent on websites, but then it gets a step higher, because instead of you refusing to give me 10 drinks, because I keep asking, give me a drink, give me a drink, give me a drink, and you get tired of me, now I have 10 of my friends that come. Those 10 friends are also asking, give me a drink, give me a drink. It becomes, the effect gets multiplied, because you probably decide that since this crazy young man keeps asking for beer, I'm not going to serve him anymore. But guess what? I go back and I talk to 10 people, give them a tip. Those 10 people come and also start asking. So that's what distributed denial of service is, because now you have different requests coming from all over, and then you deny them service, and then your website crashes and goes down. Now nobody can request beer anymore. Nobody can enter into your house because you have decided to lock the door, because all those requests are fake and it's eating up all your resources. So does that make sense in this case? So the reason that distributed denial of service is handled very well with the cloud is because it's a service that's provided over the internet by default, naturally. So they create a network that is more robust and secure to handle that. We'll talk about the network next week, because those are the 3 main services that are provided by the cloud. The compute network, the compute service, which has to do with the CPU, right? Computing things. The network service or networking service, which we're going to talk about in depth, as well as the storage service, which, like we said, talking about the RAM and the different ways in which you can store data on the cloud. Sounds good?
Yeah.
Yeah, so these are all things that make you benefit from using a cloud. Imagine that you are using your server locally or in-house. If you're using it in-house, you will probably not be able to handle distributed denial of service. You will not be able to handle different levels of security. You probably just have a very difficult time managing that. Now, finally, the last one, or the last major benefit, is manageability, meaning you're able to manage things off the cloud and things in the cloud. On the left-hand side, you can see we're talking about the management of the cloud. With the management of the cloud, we are able to automatically scale based on the need, like we have talked about. We are able to deploy resources based on pre-configured templates. Like I said, you have templates that you can use that can manage things for you and make you compliant. And we're also able to monitor the health of the resources. So you're checking your virtual machine, you're checking each of the resources and all those other resources, the website that you're deploying, so that you can automatically replace anything that is failing. For instance, that distributed denial of service. So that monitoring that takes place to check the health of your resource, automatically replace anything that is not working correctly. Finally, you can also set up alerts, right? That will be based on a configuration metric. For instance, if I'm getting up to 80% capacity of my RAM, send me an email, send me a text, send me a notification. Or if I'm getting to 80%, increase it. So all those alerts, the automatic replacement, the scalability, the use of templates help us to be able to manage the cloud. So that's the one option of it. The other is, how do we manage things ourselves in the cloud? In the cloud, you can decide to use the web portal. Okay, these are some of the things that I asked you to read up on it yesterday. So the web portal, what is a portal? A portal is like a bucket, right? A bucket or a basin or whatever that's holding things together. So that portal is what carries all your resources. We'll talk about it very well tomorrow. So whatever resource you want to deploy, they are all found in the portal, and you're using a website to get to it. So that's a web portal that can be used to manage things in the cloud or manage resources in the cloud. If you don't want to use the portal, because the portal is the front end, again, front end versus back end. Front end has a graphical user interface that you can see clearly, it looks nice. The other option is using the back end. The back end has a command line interface, what you mostly see as a black background or a green background. That's CLI, stands for command line interface. So as you use that, or as you also use this PowerShell. PowerShell is another version of the command line interface that's used by Windows machine. So Windows machine uses CLI, and the bash is used by Azure CLI. But we'll talk about that as well in depth tomorrow. But another one you might want to use is APIs. All of these are interfaces. What is an interface? An interface, again, is just something that separates two faces, right? So for instance, application programming interface separates two applications. One application needs to talk to the other application, it uses an API. So the application programming interface is the bond between those two interfaces. The command line interface is the interface between your application and the hardware. Hardware, again, whatever you're using to input, maybe voice, typing, or picture, and so on and so forth. So that's what an interface is in a nutshell. Does that make sense? So those are all the ways that you can manage a server. With that, I'm going to give you a quick quote to clear your brain a little bit. And the quote here tells you technology is anything that wasn't around when you were born. I don't know how far that is true, if everybody is in accordance with that, but I think that's pretty neat, right? So that's it. What do you have to add, Mr. Fred?
Not just saying technology is anything that wasn't around when you were born. I think it makes sense in the sense that technology is very dynamic. It's not static. So
Exactly.
you are born today with the current technology, and then by tomorrow you realize that, okay, you're entering a new phase of technology. So it changed constantly.
I know. I mean, think about us back in the days when if you go to school with a Walkman, everybody sees you like a star.
Exactly.
I mean, when the first time I bought a diskette was in 1995. I was proud of myself that, man, I have storage that I can store stuff. I can type it, email. I was a star, actually, even at UB. I'll take my diskette and use it on the computer, type everybody's email. When we go to the cyber cafe, I just put the diskette. In 2 minutes, the email is sent. And they'll be like, wow, instead of paying 100, 200, 500 per hour to be able to type a long email, you bring your email, I type it all up for you in the diskette, and I go and post it. On the way back, yeah, floppy disk. On the way back, you just buy me one corn and give me 2 plums, and I'm good. The next day, you find something else to eat. So that was big. That back then, that was technology. And then you have CDs, DVDs. Nobody even uses CDs and DVDs today. Everything now is, YouTube, and I mean, even iPods, they're not even in use anymore. So that's how much technology moves really, really fast. All right. So we've been going for about 1 hour so far today. It's about 15 minutes after the hour. But at this point, I believe we've covered everything that we needed to cover, right? We've been able to describe the benefits of high availability and scalability. We also talked about reliability and predictability. We talked about security, governance, and finally, we just talked about manageability. So what questions do you have for me? Does everything make sense, or is there anything that was problematic? No questions? Well, today is going to be a short day for you. I'm going to give you guys back 1 hour to go ahead and review everything that we've done, because this is the end of the first section. A few terms that I'd like you to also remember. We talked about high availability, usually shortcut is HA, and uptime, SLA, scalability, horizontal and vertical scaling, which could be either up, down, in and out. Reliability, again, it's one of the Microsoft Azure architected framework pillars. Predictability, that has to do with performance predictability and cost predictability. We talked about security, governance, and compliance, as well as manageability. Some of the tools that we'll be looking at are also outlined out there. You can research more on that. Tomorrow, we're going to jump into the next domain. So far, we've been able to cover about 25 to 30% of the content that you'll be seeing in the, not assessment, I keep trying to say assessment, the certification exam. Okay. So